Vanakkam. Right. So now in this video we are going to discuss about the structural isomerism in coordination compounds. Right. Structural isomerism in coordination compounds. See here. So there are different types of structural isomerism. The first one is coordination isomerism. This isomerism is found when both cation and anion are complex ions. Complex means what? It must be having or it must be present along with the ligands when both of them are complex ions. Example, see here. Here, cobalt is coordinated to 6 ammonia molecules. This is the cationic species, and chromium is coordinated to 6 cyanide species. This is the anionic species. This constitutes a complex compound. It is a complex compound. It's isomer. It's a isomer. We are going to write the isomer. See here. Here, chromium is connected to 6 ammonia species and cobalt is connected to 6 cyanide species. What is the difference between the two? Here, the coordination bond is found between ammonia and cobalt. Whereas here, see, ammonia forms coordinate bond with chromium, another metal. But this formula is same. This type of isomerisms are called coordination isomerism. Right? Then, coming for ionization isomerism, nothing but they form different ions in solution. When dissolved in solution, they will give rise to different ions but having the same formula. See here, cobalt with 5 ammonia molecules and a sulfate will have bromine, right? And its another isomer is cobalt, another compound is pentaamine, sulfate in and bromine out. So when dissolved, the same compound I have written, So it is bromide inside and sulfate outside. See here, when this compound is dissolved in water, it will give bromide ions. Right? Bromide ions in solution. But here, will you get bromide ions? No. This complex ion and you will get sulfate ion in solution. Clear? Right. Then, coming for linkage isomerism. This isomerism is observed in ambidentate ligands. I have already mentioned what is ambidentate ligand. Having more than one donor atoms. More than one donor atoms. See here, example, cobalt, pentaamine, nitrito with 2 chlorine atoms, and the another isomer is cobalt, pentaamine, nitrito with 2 chloride species. See here, nitrogen of nitro group is the donor. It is the donor for cobalt, whereas here oxygen of nitrito group is the donor for the species. Clear? So here the donor is nitrogen, here the donor is oxygen. The linkage is by means of nitrogen, the linkage is by means of oxygen. It is called as linkage isomerism. Right. Finally, hydrate isomerism. It arises due to the displacement of water or solvent molecules. See here, if water is displaced in and out of the sphere, it is called as hydrate isomerism. If generally a solvent other than water, what are the solvents like ammonia, ethanol, alcohols? So such compounds, they can be displaced in and out of the coordination sphere and they are called as solvate isomers. Example, we can write the chromium complexes. So chromium is coordinated to 6 water molecules and in ionization sphere there are 3 chloride ions. Then chromium is coordinated to 5 water molecules and a chlorine. So just one water molecule has got out and one chlorine in. It is called as displacement, right? Hydrated salt it is. So similarly another formula is also available there. Another compound is also available there. Again one water molecule out and one chlorine in. So it is violet in color. It is the dark I think bright green and a dark green. We don't need about the colors here. So here the compounds are having same molecular formula, but the isomerism is due to the displacement of water molecules in and out of the coordination sphere. So such type of isomers are called hydrate isomers or solvate isomers. Okay. So I think we are all very familiar with the structural isomerism concept. In next concept, we will discuss about the geometrical isomerism and also optical isomerism, which are categorized as stereoisomerism.